So now we've added means and standard deviations to worksheet 2 here. So on any test, I look for 4 points. So we'll talk about the 4 points, but the first point is that you draw a curve. And it says the mean is 18. So if I were to put an 18 in here, then it says x is greater than 19. So 19 is somewhere up here. All I would look for on the test is, did you shade to the right, because that's the greater than side. So that'd be 1 point. Next, I would look for a z-score. So z equals x, 19. Subtract the mean. Remember, you always subtract the mean and divide by 3.2. So 19 minus 18 is 1. 1 divided by 3.2. I'm going to do that in the calculator here. That is 0.31. So our z-score is 0.31. Now, we just got done doing this, where now what you're going to do is you're going to go from 0.31 on up. So you're going to go from 0.31 to 999. Okay? So now we use our normal CDF. Menu 652. We go from 0.31 to 999, and it's the same thing you just did in the first 10 problems, and we get 37.8%. Now, again, so that would be a point. Now, the last point, the fourth point, is context. Okay? We don't have any context here because it's not talking about these being quiz scores or these being ball bearings or anything like we did in the notes. So there is no context. So if this was a test question, it'd only be 3 because we don't have a contextual part of it. But that will get added later. Now, you can do it this way. I'm going to do it for the sake of this. We could go menu 652. So you might want to try this. You can put in the 19 here, and the upper bound is 99999. But if you put in the raw score, then you would put in the 18 and the 3.2. Now, it's going to be a little bit different. It's still about the same, 37.7, but the reason is I rounded that z-score from before. If I didn't round that z-score, we would have got an identical answer. Okay? So this one, same thing, greater than 16.5. Well, 18 is our mean, so 16.5 is below the mean. So we're expecting to be greater than, so it's going to be a lot of the curve. We're expecting an answer, well over 50%, maybe 70%, something like that. Again, you would do a z-score, so you go z equals 16.5, subtract 18, always subtract the mean, divide by 3.3.
3.2.
Is it 3.2? Yeah. Divide by 3.2 to get it right, and get negative 0.31 if we round. So our z is negative 0.31. Now you would go from negative 0.31 to 999. You want to do it 308 like it had it, that's fine. Be more accurate. Then if you did it with the raw scores, you could do it. Again, the raw scores, you could go from 16.5 to 99999, put in the 18 and the 3.2. But this one should have gotten about 62.1%. Okay, this one, number 13 is kind of like what we did in numbers like things like numbers 7, 8, 9, and 10. It's between 2 of the z-scores. So again, the 18 is here, and you're going from 14, which is somewhere down here, up to 17 and trying to find that area. And you're shading in between. So now you're going to need 2 z-scores. Okay, so I'm going to write them on the board quick so I don't have to write them with the mouse. It'll be a little faster. I'm going to get this one set up while I'm at it. So this one goes from 15 to 18. So this one's going to require 2 z-scores as well. Z equals that, 15 minus 18 over 3.2. Hopefully you recognize that one as a z-score of 0 because it's right on the mean. Any z-score right on the mean is a z-score of 0. But now we got to get these, the first one, -4 divided by 3.2. That's -1.25. The next one, I think, is 0.31. It's a -0.31. -1 divided by 3.2.
Yeah, -0.31.
Okay. And I knew that just from looking at number 11. That was a positive 0.31. It was one away. If that makes sense, that's the symmetry of the curve. And then -3 divided by 3.2 on the last one, -0.94. Okay, now you're going between those, so you can use the z-scores. So we do a menu 652, and we go our lower bound and upper bound.
Our lower bound would be -1.25, right?
-1.25. -0.31, right?
Yeah.
Yep. So that was 27.3%.
You said 27.3.
Yep. And then the next one is -0.94 to 0. It should be 32.6%. Now, in stats, we're not like calc where we worry about rounding at the end of the problem. Some people round in the middle of the problem, and you're going to get different answers. Anyway, hopefully, does that all make sense through 14, everybody?
Yeah.
Okay. All right. 15's really, 15 and 16 are really the same thing. Let's just keep plunging ahead here. So it says the mean is 107. So I'm going to quickly put in 107. 90 would be down below the mean, and 109 would be up above the mean. I'm going to make a quick sketch. That's the area. I'm going to do the z-scores on the board so I can write them a little faster. So I'm going to set this one up too. So this one, I'll do it at the board. So this one will have 2 z-scores. That'll be our lower bound. And this will be our upper bound. Whoops, that's 109. Okay, so the first one should be -17 divided by 12, which didn't give me a decimal because I didn't put a dot on there.
Wait, would you get -17 and 12?
I took the 90, subtract 107. That got me the -17. So we get -1.42.
Wait, isn't the standard deviation 32?
Yes, so let's divide it by 32. Good catch. Would have had all those wrong. So thank you. All right. That's what everybody else watching the video now is going, where were you getting the...
The small error.
Yep, little just brain meltdown. All right, so -0.53 should be the first one. And 0.06. Next, -19 divided by 32, -0.59. Correct me if I have any of these wrong. And then the next one is -2 divided by 32. This is going to be a real small z-score, close to 0, -0.06. Oh, should have been recognized it. These two are exact opposites of each other. They're both 2 away. All right. So now, menu 652. This one is 23%, roughly. And again, the rounding doesn't matter. If you're like 22.6 or whatever that is, that's great. Negative 0.959 here, menu 652, negative 0.59 to, is it negative 0.06?
I think your bottom right Z-score is wrong. I think you did 102 instead of 107.
Okay. On this one?
Yeah, that one right there.
This is,
Yeah,
oh, I did. It's supposed to be 107. So correct. Thank you for fixing that.
I got negative 0.21.
Negative 0.21. Okay. And what's the area? Did you do the area yet?
Oh.
About 14%, 13.9.
Yeah, I got 13.9.
Okay. Perfect. Thanks for fixing those. It's always better when you do them at home and you make a mistake, then you can't really fix it. Okay, number 17, what Z-score is the 85th percentile? Now remember, the percentile is the area to the left. So if I draw a line and I put 85% here, what is that Z-score? Now we're starting with a percent, so now we're doing the inverse norm, okay? So because they start us with a percent, so this is the first one we've done this way. We're going to go menu, 6.5, and then number 3. And the area you put in always has to be the area to the left. So in this case, the area to the left is the 0.85. And it will return for you a Z-score, and that Z-score is 1.036 or 1.04. Now, if you were to turn around and you were to go from negative 999 to 1.04, and I'm just going to do it for the sake of doing it, menu 652, negative 999 to 1.04, we should get 85%. Okay, that's what we get. So those two features are the opposites of each other. Number 18. What Z-score cuts off the highest 22%? Now the highest 22% is somewhere on the right, but the inverse norm feature does not do areas to the right. So you have to first take 1 and subtract 22% and get 78. And that's what's got to go in for the area. So we're now looking for this Z-score. We go menu 653, 0.78, and we get a 0.77 Z-score, which is kind of weird. It just seems like, but you have to recognize what's a percent and what's a Z-score. That just means we're somewhere between 0 and 1 as far as our Z-score, okay? 19, what Z-score cuts off the lowest 60%? Well, the lowest 60% would still be somewhere above the mean to have 60% underneath it. But again, then we just go menu, 653, put in the 0.60, and we get Z equals 0.25. 253. Remember, that's a Z-score, not a percent. So many times students get these back and then they write 25%. This is a Z-score, so it's somewhere between 0 and 1. It's about a quarter of the way between there. Okay, now we're adding some numbers. So in the Z 20, 2.5, what is the lowest 30%? So first, we got to recognize lowest 30% would be somewhere down here at a negative Z-score. And now this type of problem, here come the 4 points again. Oh, it's only going to be 3 because we don't have context. But you first want to do an inverse norm, menu 653 of 30%. I get negative 0.52. That's the Z-score. Now remember, Z equals X, subtract the mean is 20, divide by 2.5, and then you're going to solve this either algebraically or let the calculator do it for you. So how do I solve that? I would multiply by 2.5, and then I would add 20. So the answer is x is 18.7. Remember, this is the mean of 20. So that 18.7, you always want to see, does it make sense with the number line on the curve? Okay, so now you can do this the fast way. You can go menu 653, you put in the 30, you put in the 20, you put in the standard deviation of 2.5. It'll give you the answer right away. The disadvantage, you won't have the z-score, and I want to see the z-score. I want to see that work. So this would be 3 points, one for the curve, one for the z-score, one for the answer. If there was a fourth point, it would be for context. Okay. So I know we're running close to out of time, but we're going to try to, I'm going to save 21, and I'll do it after, maybe here on another video or something. So